This is our mathematical model of hair-plucking birds. We're Brooklyn Price, Addesyn Marshall, and Abigale Goulding.
Everyone knows what a bird's nest is. However, not everyone knows that hair is a major component to birds' nests. Many birds in the genus Hair-Plucking have hair in their nests, but some of these birds obtain the hair through plucking it off of live animals. This leads us to ask the questions, what are the benefits of having hair in the nest? The follow-up question is, what are the benefits of freshly pulled hair over gathered hair?
This is our schematic diagram of the flow of population of birds genus Hair-Plucking. We will use this diagram to show the different death rates of each type of bird and compare them. It shows that adult birds can go into 3 different categories. It can go into gathering hair, it can go into plucking hair, or it can go into no hair at all. Those 3 groups of birds then go into 2 groups of a nest with hair and a nest without hair. We did not split up the gathering and plucking into 2 different nests at this point. We will do that later on, but for a basic look at the whole population, we just kept it with those 2. These are our basic parameters that many were found through research, such as the birth rate and how long it takes different birds to build their nests. However, some of our parameters are done through calculation. We use the lifespan and confidence intervals to find the death rate and the added survival rate of birds. We use those confidence intervals with the lifespans to find the average lifespan of each bird. And so then from there we could say how long they live and find a death rate for those. Then we could find how long birds with hair or birds that pluck, how long they live, and that's the added survival rate.
Before we go into the results, we will explain the assumptions we made for this model. First, we assume that half of the population of birds is female and the other half is male. Secondly, one of our sources states that 10 out of 11 times the live animal that the bird is plucking hair from has no reaction to the bird plucking hair. We assume that the 1 out of 11 chance of the animal noticing the bird results in the death of the bird. Third, we assume our dataset represents 100% of the population of birds of genus Hair-Plucking. Fourth, we found from a source that most birds of genus Hair-Plucking do not live to be a year. Thus, we assume that 90% of birds do not make it to adulthood. Fifth, when studying the results of our model across different climates, we assume the total population is split evenly across the climates. Finally, we assume if a bird has hair in its nest and it didn't pluck it off of a live animal, it gathered the hair from carcasses or off of the ground. When considering why some birds pluck hair off of live animals, we thought of the possible benefits of a bird having hair in its nest. We thought that insulation and warmth could be a possible benefit. We also thought that the hair in the nest might deter predators from finding the nest. Then we considered why plucking hair might be more beneficial than gathering hair for a nest. We think that the hair from live animals might give a stronger scent than hair from the ground, thus having a higher chance of deterring predators. Another possible benefit of plucking over gathering could be less time having to find hair, thus building a nest much faster.
In order to model this behavior within the bird population, we created the following differential equations to form a compartmental model. So these equations represent the birds moving from one group to another. So the first equation is the baby bird population, and it is the rate at which baby birds are coming into the population and the rate at which they are leaving to go to the adult populations. As you can see, we account for baby birds dying as many of them do not make it to adulthood. The rest of the equations represent the adult population of the birds. Once the birds reach adulthood, we split them into 2 compartments, birds with hair in the nest and birds without hair in their nest. And for the compartment of birds with hair in the nest, we split that into 2 groups, which contains the birds that pluck and the birds that gather. And so these equations track how many people are in the population at a certain time and how many of them are dying.
These graphs show the population growth in 1 year for birds of genus Hair-Plucking. As you can see, we broke down the population by birds with hair in the nest and birds without. The graph on the right breaks the population of birds with hair in the nest into 2 categories, birds that gather and birds that pluck. When interpreting these graphs, we must keep in mind that 2% of the total population plucks hair off animals, 84% of the population gathers hair, and 14% have no hair in the nest. Now we have graphs that compare the death rates of the different categories of birds. We can see from the graph on the left that birds that pluck hair have an initial jump in their death rate, but come to be even with birds that gather hair and birds with no hair by the end of the year. This is because birds that pluck hair have an added 1 out of 11 chance of dying from a bad encounter with a live animal. However, the graph on the right shows that out of the total population of birds, the death rates of birds with hair in their nest and birds without hair in their nest are almost exactly the same.
Earlier in this presentation, we discussed that one possible benefit to having hair in the nest could be warmth. In order to see if this is actually a benefit, we broke down the population by climate. And then from there, we broke down the climate into groups of birds with hair in the nest and birds that do not have hair in the nest. From there, we took the birds with hair in the nest and we calculated the percentage of them that actually pluck the hair for their nest. Note that out of all the birds, 86% have hair in the nest, yet only 2% pluck. In the breakdown by climate, it can be observed that the only population with a bird that plucks hair is a subtropical temperate climate. Additionally, it can be seen that in all climates, at least 50% of birds have hair in their nest. This implies that there might be another advantage to having hair in the nest that doesn't coincide with temperature. We propose that although temperature might play a role in having hair in the nest, there has to be something else to make it such a widespread feature across all these different climates. We will discuss these other possibilities later in the presentation. In the tropical climate, we have the lowest amount of birds with hair in the nest. This can also support the theory that insulation plays a large role in having hair in the nest. However, with such a widespread amount of birds of varying climates with hair in the nest, it is clear that there is something more to this reasoning. These were our results for birds within a tropical climate. As you can see, the ratio of deaths for birds when they're building a nest, the birds that use hair in their nest, it's a little bit higher. But once the birds have that nest made, the ratio of birds dying happens to be lower for the birds that have hair in their nest. And that can possibly be attributed to possible predator benefits and other such things.
Here you can see the results of a subtropical climate. In this climate, we only have birds with hair, so we're just looking at gathering versus plucking. You can see here that in building a nest populations, they're fairly similar to what we found before in those initial results. However, our birds with a nest are very different because we have split the nest into gathered hair and plucked hair and given the plucked hair an added benefit, which we think could be caused not just by temperature. Because of this added benefit, the ratio of deaths for plucked hair remains constant as the model goes on, whereas gathered hair dips and then increases throughout the model. The population of plucked-haired birds also remains pretty constant throughout the model, where gathered hair goes up and then it starts to come down near the end of it. As previously discussed, although temperature can play into the need for having hair in the nest, there may also be another reason for using hair. This reason would have to do with predators. Often hair carries scent. By using the hair from a predator, it may be possible for a bird to trick possible threats into thinking there's another predator in the vicinity and deter animals from attacking their nest. The scent on plucked fur will be fresher than if it's found. Plucking also saves time for those birds that need hair. It's easier to find one source and get all your hair there than walk around and find a little bit of hair everywhere else. It also can help misguide lice. Lice will get into the feathers of birds, but if you have hair in your nest, the lice can chew on that instead of on your feathers.
If we had more time for this project, we would be interested to gather some data on birds that pluck hair from live animals that are not of genus Pairidae and study those death rates and benefits. We could also explore more possible reasons for plucking hair other than insulation for the nest. We could possibly model the benefits of the scent of hair in the nest. There is a lot more interesting work that can be done on this project.
We would like to thank Dr. Vinodh Chellamuthu and SCUDEM for this opportunity.